Alright, in this problem we're given sine of n divided by 8n, and that's a sequence, and we're asked to find the limit and or determine if the sequence diverges. Okay, so let's take a look at this. We've got a sine function on top, and you know a sine function oscillates. Okay, so it goes up and down, up and down. Okay, and then the 8 to the n function, well, as n gets larger, say it's going to start with n equals 1, 2, 3, and so on. Okay, so as n gets larger, this denominator gets larger very quickly, and that means that that oscillation is going to be divided by a increasingly large number. Okay, so if you look at the sine function by itself, let me pull that up for you. Okay, you might remember, maybe we zoom to a better window than that. There we go. Okay, so you might remember the sine function oscillates. Okay, so ignore this over here. In fact, I'll change my window to ignore that. I'll go from 0 there. Okay, so it goes up, goes down, and it has a period of 2 pi. So imagine this function is constantly being divided by bigger and bigger numbers as it goes along. Okay, so if you're dividing something that gets to a maximum of 1 or to a minimum of -1, but you're dividing it by bigger and bigger numbers, that maximum minimum is going to get closer and closer to 0. So this thing, as it goes along, is going to get closer and closer very quickly until it's right on 0. Okay, so given that, we are going to try to use what we call a sandwich theorem. I'm going to look at two other. We'll call this one A sub n. And so let's look at B sub n, and let's call B sub n -1 over 8 to the n. And the reason I use -1 is because -1 is the absolute smallest that sine can be. Okay, which means now I want to get the absolute biggest that sine can be, and the biggest maximum value that sine can ever take on is 1. So C sub n is going to be equal to 1 over 8 to the n power. So what I have is one of these sequences that I just made up represents the absolute smallest that this sequence could ever take on, and one of them represents the absolute biggest that this sequence could ever take on. So what it's more than likely going to look like is you've got this, let's see, up here at -1 over 8 to the n. So you've got this upper bound, and you've got this lower bound, and this, of course, the upper and lower bound are increasingly getting closer and closer to, as you go out here, they're getting closer and closer to 0. Okay, and if I can prove that this is in between these two, and I can also prove that both of these are going towards 0 as you go out further and further, as your n values increase. If I can prove that A sub n is between these, which I have, because sine function does take on a minimum of -1 and a maximum of 1, now I just need to prove that both of these two sequences converge to 0. Okay, and that's pretty easy to look at. You can look at the -1 over 8 to the n power, and if you just plug in some bigger and bigger numbers into n, you'll get -1/8, and then you'll get -1/64, and so on and so forth. And this the same here, 1 over 8, 1 over 64, and so on and so forth. So both of these converge to 0. Okay, and since this is true, then A sub n converges to 0. So the limit of this A sub n, as n goes to infinity, is 0, and it converges to 0.